Okay, so we've collected the 4 time series, which were called this one, this one, this one, this one, and this one. And now we're just going to combine them all using cbind. So we're going to have a matrix, right? Or it's not going to be a matrix. Oh, time series. All right, let's see what happens. So I just did head on this, and we have this one, and this one, and this one, and this one. And you can see now that, okay, so we have 4 columns, and the date doesn't show, does it? And that's because if we do this, this doesn't have the date either, right? This just has the data without the date in it. Okay, but I believe that the date is embedded in there. Okay, now you might say, wait, this looks strange. There's nothing here, 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 and here. And that's because this one apparently started before these did. So these are empty. And now he's going to give simple names to this. Oops. Because right now we have these long names here. So he does this. And then if we run the same command again with head, whoops, not that one, sorry. This one. Now we have simpler names. And now he's going to get rid of what? Rows. Remember this function we did before? Get rid of rows that have any row that has an NA in it. So it might be getting rid of a lot of data, but that's what we're doing here. Okay, so that's when we get rid of that, then we'll be able to do modeling. So he calls it modeling MTS instead of economic MTS. Okay. Now we do that, and then if we try, so like this row will just be deleted. So now if we do head on that, we get only rows where there were all 4 columns had data. And now we can plot all of that. And we get this. So now we have this part here. The resulting plot provided in figure 5.1 shows the Great Recession. So we saw that already. Okay, next we're going to do this. It says parallel indexing can be especially useful in the analysis of multiple time series. The University of Michigan Index of Consumer Sentiment is indexed IQ first quarter is 1996 is 100. So that's the way it was set. Let's look at that series. So here's the head. So this looks like the first date was 1978, but he says, and it's not 100. Oh, consumer sentiment, sorry. Right. So so apparently it was indexed, where is that? It was indexed calling consumer sentiment was equal to 100 in 1966, first quarter. So now, in the first data that we have, it has gone down. Consumer sentiment is lower. Okay. So in 1978, January 1st, the consumer sentiment was 83.7% of what it was in that earlier date. Okay, now, he says, consumer sentiment went back up in 1997, back up to 100. That means it was equal to what it was here. And it doesn't mean it can't go above 100. It could go above 100. But that we call whatever it was at 1966, we called that 100. And then, of course, it could go higher than that, or it could go lower. Anyway, it was back up. It was at 100 in March 1977. So it was basically the same as it was in 1966 first quarter. He says now this date, we have observations for the 3 other series. So using March 1997 as our reference date for the 100 index value, we can compute like indexed series for the employment rate, the durable goods orders, and the new home sales. That is, each economic measure can be scaled so that its value at the reference date of 1997 is equal to 100. So we just scale them so that they're all equal to 100 in 1997. And that way we can sort of look at the graphs and maybe see things more clearly. So we will use March 1997 as our base month for converting the other three economic indicators to index values. With each economic measure scaled to that value as 100, we can plot the multiple time series again using a horizon plot, and that's what I showed you before. So we're going to have a horizon plot. We're going to have 4 horizon plots. By the way, let's read these notes. According to the Business Cycle Dating Committee of the National Bureau of Economic Research, the Great Recession extended from here to here, the longest of any recession since World War II. Okay, also 2. What's 2? Where was that? That was here. Let's see what that's about. The mathematics for parallel indexing is straightforward. Let xt be the value of the economic measure at time t. So whatever, it's just the value of the economic measure at time t. That's the original value at time t. And let x0 be the value of the economic measure at the reference date, which is our 1997. So if you want to figure out what it should be at time t, using the new index, in other words, setting at this one will be called 100, then what is it at this time? You just say this is what we're going to call it, and it's just this one over that one. So let's say, okay, let me give you an example. Suppose that the actual value of whatever we had, it wasn't this one, but let's say employment was equal to whatever, 90%. Suppose it was 90 at this date. Now we're going to make that 100, and then suppose it went up to 95 1 year later. What should we call that? So it's going to be, it went up to 95 1 year later, so what should we call that? It's going to be 95 on the top and 90 on the bottom, because I said it was 90 at x0 originally. So what's that going to give you? 95 over 90, so it's going to be like whatever, 100 and some more than 100, right? Percent, or actually more than 100 when you multiply it by 100. So that's what they mean. Okay, I don't know if I did that very clearly, but think about it. Okay, now the horizon plot. So it was introduced by these guys in 2009, and it represents a space-efficient data visualization for multiple time series. Okay, so you can read this, but we're going to make that. Okay, let's stop here, and then we will come back to how we're going to accomplish all this stuff of creating the indices so that they're all equal to 100 in 1997 March.